Greetings, my name is Ivan Pratt and welcome to my second Capstone presentation. This time, since I'm specializing in cybersecurity, I will be showcasing a simulated real-life attack on a website login. Please do note, this is not a 100% realistic depiction of attacks we see in the wild. Let's pretend for a moment that I am a security enthusiast who wants to deal some damage to the website of a fellow web developer. Here is my made-up victim's web page. The way I'm going to go about attacking the site is to simply guess her credentials until I get in. While I could guess every character from A to Z, this literally could take days. Taking advantage of the human element is a great way to cut down the attack time to something more reasonable. Here we have Mr. Chauffeur's, my victim's, Instagram account pulled up. I see he has a photo of his dog, Bernard. Look, yes, pet names are very popular passwords among pet owners. I'm adding this to a text file of password candidates. Another photo we can see on his profile is this one here of his kid getting a jersey signed for a sports team. Let's go, Mustangs. Speeding this up, I am also adding Mr. Chauffeur's address, birth date, first and last name, username, and etc. to the list. Also adding the names of the only 3 people he is following: Bill Gates Quotes, and Billie Eilish. The Instagram bio also says we should check out his blog, So We Shall. Here it is. So what's the attack vector? Skim through the entire blog and pick out password candidates like we did on Instagram? Not quite. To find password candidates in this huge amount of text, I'm copying and pasting it into Google Sheets, adding all English words and removing the duplicates. Now our words are uncommon, unique, or mostly non-dictionary words. Now we build out the word list. A tool called The Mentalist creates variations of passwords extending what we already have on our base word list. Oftentimes, passwords end in an exclamation point or some other symbol. I'm sure we've all done this to meet security requirements. Let's add an append rule to every word with a couple of these commonly used symbols. We will also try capitalizing and decapitalizing the first letter of every word. Let's process the file to a dictionary. Quickly taking a look at it, you can see all of the permutations of our original word list. Now that we have our password dictionary, let's attack the web app. Now, were you expecting me to switch over to a Linux desktop or maybe Kali virtual machine? Wrong. I will use Windows. No Linux for you. But Ivan, hacking is always done on Linux. No. If this is you, meet me outside in the parking lot after class. I have copied here the exact command line phrase to execute our attack. This tool, called THC Hydra, runs 16 post requests in parallel using the username admin and each of the passwords specified in our dictionary file we created until it gets a successful login. I'm speeding this section up here because this may take a moment. And voila! You can see that we have successfully located a password based off of the blog words. You can see the password is qubits! Something that I probably would never have guessed. It was a good try, Isaac. Too bad you fell for the classic blunder of writing the word on the public internet one single time 5 years ago. On the web app, let's confirm that the credentials work. Username, admin. Password, qubits. Success! We are now logged in as admin. Nice homepage, Isaac. Note to developers: to defend against this attack, Isaac can simply implement an account lockout feature. For example, blocking a user from signing in for a few minutes after they attempt a wrong password 5 times in a row. He could also implement 2-factor authentication, though you may be surprised that that is quite easily bypassed as well. Talk to me later for more details on that. Anyway, that is all. I hope Mr. Chauffeur has learned from his mistake this time and will implement more security features into the site in the future. This was my capstone project, and I enjoyed studying at Dev Mountain.